Good day, everyone. You are welcome back to Idowu Maths class. This is another day. Before we go into the business of the day, let's look into the solution to the assignment of our last class first. Here is question number 1 of the assignment. Solve 2 raised to power x plus 1 plus 2 raised to power x equals 24. When you have it this way, don't forget, you rewrite as 2 raised to power x times 2 raised to power 1 plus 2 raised to power x, which is equal to 24. 2 raised to power 1 is 2 times 2 raised to power x. That gives us 2 into 2 raised to power x plus 2 raised to power x could be rewritten as 1 into 2 raised to power x, which is equal to 24. So look at this as 2 into 2 raised to power x plus 1 into 2 raised to power x, which gives us 3 into 2 raised to power x, which is equal to 24. Dividing both sides by 3, we have 3 into 2 raised to power x divided by 3 equals 24 divided by 3. So this gives 2 raised to power x equals 8. You express 8 in index form as 2 raised to power x equals 2 raised to power 3. Therefore, x is equal to 3. I hope you understand. Here is question number 2 of the assignment. Find x if 2 raised to power x plus 2 times 12 raised to power x minus 1 times 6 raised to power x plus 2 is equal to 1. What do? You can see that 2 raised to power x plus 2 and 6 raised to power x plus 2, they have the same power. And when two values have the same power, then you can multiply them together to maintain the same power, meaning that 2 raised to power x plus 2 times 6 raised to power x plus 2 can give us 12 raised to power x plus 2. I hope you understand. So times 12 raised to power x minus 1, that has been existing there before, equals 1. Don't forget, in the normal rules of indices, having this common base, we pick one of them, raised to power x plus 2. The multiplication sign changes to addition in the exponential region. You have plus x minus 1, which is equal to, in the place of this figure 1, you now put the current base in the operation. You put it in the place of 1. You now raise it to power 0. So you have 12 raised to power 0. 12 is the current base here. So you raise it to power 0. Don't forget, anything raised to power 0 is 1. So now we are having common base across the two sides of the equation. That means the powers on the two sides of the equation also are equal to each other. This means x plus 2 plus x minus 1 is equal to 0. So x plus x gives us 2x. 2 minus 1 gives us plus 1 equals 0. So solving the linear equation by collecting the like terms, you have 2x equals minus 1. You divide both sides by 2, you have 2x divided by 2 equals minus 1 divided by 2. Therefore, we have x equals minus half. And that's the end of that equation. Question 3 of the assignment. Solve 4 raised to power x minus 2 raised to power x minus 2 raised to power x plus 1 plus 2 equals 0. 4 raised to power x could be rewritten as 2 raised to power 2 or raised to power x, while this could be rewritten as minus 1 into 2 raised to power x minus 2 raised to power x times 2 raised to power 1 plus 2 equals 0. This could also be written as 2 raised to power x or raised to power 2. They are the same. Minus 1 into 2 raised to power x minus 2 into 2 raised to power x. Let me explain that. 2 raised to power 1 is 2. When you multiply it with 2 raised to power x, it gives you 2 into 2 raised to power x. And this negative sign is for them, plus 2. So, while this is 2 raised to power x raised to power 2 minus 3 into 2 raised to power x plus 2 equals 0. See how? This is minus 1 minus 2. Minus 1, 2 raised to the power x, minus 2, 2 raised to the power x. That gives us minus 3, 2 raised to the power x plus 2. So at this juncture, you let 2 raised to the power x be equal to a letter of your choice. I choose B. So wherever you see 2 raised to the power x, put B in place. So I have B squared minus 3B plus 2 equals 0. This is a quadratic equation resulting from that. Solve the quadratic equation. B raised to the power 2 minus 2B minus B. Minus 2B minus B gives you minus 3B. Minus 2B times minus B gives you positive 2B squared, which is the product of the first term and the last term here. That means we are okay with the factorization. After all, I've taught you that. I'm only referring to it. Plus 2 equals 0. So between these first two terms, factorize B out. B into B minus 2. Between these, minus 1 is common. Minus 1 into, to divide minus B gives us positive B. Minus 1 divides positive 2 gives us minus 2 equals 0. So this gives us B minus 1 into B minus 2 equals 0. Are we following? So B minus 1 is equal to 0, or B minus 2 equals 0. B equals 1, or B equals 2. Since, come to the place where we use something to represent 2 raised to the power x. Since 2 raised to the power x is equal to B, therefore 2 raised to the power x is equal to 1, or 2 raised to the power x is equal to 2. We have B being equal to 1 at a point, B being equal to 2 at another point. So this is 2 raised to the power x equals to 2 raised to the power 0. You remember in indices? Or 2 raised to the power x, which is equal to 2 raised to the power 1. So x is equal to 0 here, or x is equal to 1. And that is the end of that equation. So the last question of the assignment, question 4. Solve 3 raised to the power 2x plus 1 minus 12 into 3 raised to the power x plus 9 equals 0. We express this as 3 raised to the power 2x times 3 raised to the power 1 minus 12 into 3 raised to the power x plus 9 equals 0. This could be rewritten as 3 raised to the power x or raised to the power 2 times 3 minus 12 into 3 raised to the power x plus 9 equals 0. So since 3 multiplies this, it is 3 into 3 raised to the power x raised to the power 2 minus 12 into 3 raised to the power x plus 9 equals 0. Are you following? So let 3 raised to the power x be equal to something, a letter that is unique, that is not represented here already. No, x is represented here already, so don't use x. So I use y. So wherever I see 3 raised to the power x, I put y in place. So here, to rewrite the equation, I write 3y squared minus 12y plus 9 equals 0. This is quadratic equation. Something is common to them across. So I divide each term by 3. So to have y squared minus 4y plus 3 equals 0. So solving this quadratic equation is all we need now. To solve this quadratic equation, we have y squared minus 3y minus y plus 3 equals 0. You know, minus 3y minus y gives minus 4y. And the product of the two of them, minus 3y times minus y, gives positive 3y squared, which is the product of this first and last term. So you can see. So factorizing the first two terms here, you have y into y minus 3. Minus 1 is common here, into y minus 3 equals 0. We have done that before. I've taught you this. This is just a, by the way, something. We have done it. So I'm just referring to it. I'm not really teaching that, you know. So we have y minus 1 into y minus 3 equals 0. Quadratic equation. So y minus 1 equals 0, or y minus 3 equals 0. You solve this simple linear equation. Y equals 1 or y equals 3. Don't forget, y is not the variable we have from the beginning. So let's refer to the representative. Since 3 raised to power x is equal to y, according to us. So therefore, 3 raised to power x is equal to, what is the value of y? 1. Or 3 raised to power x is equal to 3. Which means 3 raised to power x equals 3 raised to power 0. Or 3 raised to power x equals 3 raised to power 1. So x is equal to 0, or x is equal to 1. That is the end of the assignment. So we can now move to the topic of the day. The topic we are dealing with today is surd. What is surd? Surd is the square root of a non-perfect square number. Square root of a non-perfect square number. E.g., square root of 8 is a surd. Square root of 12 is a surd. Square root of 17 is a surd. Square root of 3 is a surd, and so forth. That is what we mean by surd. Now, let's talk about simplifiable surd. Simplifiable surds. Simplifiable surds are such surds that could be further broken into perfect and non-perfect square numbers under square root. What do we mean by perfect square number and non-perfect square number? You know, numbers like 1, 4, 9, 16, 25, and so forth. They are perfect square. Number that has straightforward square root without decimal. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. That's not the only way to define a perfect square. A perfect square is a number that could be raised in power 2 or power 4 or in any even power. Every perfect square should be able to maintain or contain any even power, like power 2, power 4, power 6, power 8. Any number that is raised in odd power is not a perfect square. That is raised in power 3, power 5, power 7, power 9, such number is not a perfect square. Now, a simplifiable surd is the surd in which the number under the square root can be broken into perfect and non-perfect square number. E.g., square root of 12. Now, this is a surd. It's a simplifiable surd because we can break square root of 12 into square root of 4. 4 is a perfect square, times square root of 3. 3 is a non-perfect square. So that's why this root 12 is a simplifiable surd. I hope you understand. Another one is square root of 8. It's a simplifiable surd, which could be broken into square root of 4 times square root of 2. That's simplifiable surd. You can see another one, if you care to get further. Another one is like a square root of 27, which could be broken into square root of 9 times square root of 3. You notice something here, that square root of 4, 4 is a perfect square under the root. Square root of 4, 4 is a perfect square. Square root of 9, 9 is a perfect square. So we break it into perfect square and non-perfect square. 3 is a non-perfect square. 2 is a non-perfect square. 3 also here. It's a non-perfect square. I want to believe you understand the concept of these simplifiable surds. Thank you. Let's move further. Simplification of surds. Example 1. What do we simplify? We simplify something that is simplifiable. That's why we have considered simplifiable surds. Now we want to look into simplification of surds. Example 1. Simplify the following. Square root of 18. Square root of 245. Question A. Square root of 18 will be expressed as square root of 9 times square root of 2. Don't forget, a simplifiable surd is the one that could be broken into perfect and non-perfect numbers under square root. So, this is it. So, what is square root of 9? 3 times. What is square root of 2? That one is not perfect. It's not something you can say straightforward. Square root of 2 will be 1 point something. It will have some places of decimal. So, you repeat it as square root of 2. You leave it as non-simplifiable surd. So 3 times root 2 is 3 root 2. Question B. Square root of 245 will be expressed as, take 245 out. Analyze it, break it into factors. 5 goes here. 5 goes in 24 4 times. It remains 4. That 4, use it with 5, making 45. 5 in 45 gives 9. So that means 5 and 49 are 2 factors we can see first. This 49 and 5. Meanwhile, 49 is a perfect square. 5 is non-perfect square. And if you like, you can further divide it into 7 in 49, 7. 7 in 7, 1. So you can have square root of 49 times square root of 5. Square root of 49 is 7 times square root of 5, which gives 7 root 5. Let's see another example. Example 2. Simplify the surd. It's of the same format. There's no difference. But more examples will enhance your understanding. Question A. Square root of 150. You take 150 to one side of your book. Break it into factors. 3 goes here, even 2. 2 goes in 15, 7 times. It remains 1. In 10, 5. So 2 can no longer go. 3 goes in 75. How? 3 in 7, 2. Remains 1. That one, you use it with 5, giving us 15. 3 in 15 is 5. So you can see 5 goes in 25, 5 times. 5 goes in 5 one times. So you have broken 150 into 2, 2, 5, 5. So you can write square root of 5 times square root of 5 times square root of 2 times square root of 3 as, see, in surd. We are still going to that. That's why I don't rush into saying it. But now I think it is essential. It's necessary for me to say it at this juncture. In surd, root A times root A is equal to A in surd. So root 5 times root 5 is equal to 5. Meanwhile, root A times root B in surd is equal to root AB. When they are not the same, they will multiply to give a new number. So root 2 times root 3 gives root 6. That is 2 times 3 is 6. Answer is 5 root 6. Or root 25 times root 6. If you break this into 2 times 3 is 6. 5 times 5, 25. You can see that between 6 and 25, one is a perfect scale, one is a non-perfect scale. 6 is a non-perfect scale, 25 is a perfect scale. So you are still good to use them. So square root of 25 gives us 5 times square root of 6, that is a non-simplifiable surd. That's square root of 6. So answer is 5 root 6. To question B of example 2. Square root of 175. You break 175 into factors. Looking into this, 5 goes in 17 3 times. Leaving what behind? 2. So 5 in 25, 5. So 5 goes also again in 35, 7 times. 7 in 7, 1. So this could be written as square root of 5 times square root of 5 times square root of 7, which is square root of 5 times square root of 5 gives us 5, as I've told you, times square root of 7. Square root of 7 is a non-simplifiable surd. So you leave it as it is. The product is 5 root 7.